So for today, I have two goals. One is to hand back your tests, and there was probably like 8 of you who are going to have to take a retake, and that's a fair amount, as it didn't go so well. And here's what it usually boiled down to. Those kids often didn't notice that something like this and something like this can be replaced with each other. Like this red one could be replaced with the black one. Do you get that they're the same? They're like equal to each other? So if you see this red one in the middle of a problem, it's got an x plus 3 on the bottom, do you get, you need to factor it. Everybody factor that and cancel what can cancel. Factor this, cancel what can cancel. Now, I get it if you're like, I can't factor. I'm terrible at factoring. Well, then here's how you should think of it. Do you see there's a 2 in both parts? To make it easier for you, I'm going to replace this 6 with a 2 times 3. 2 times 3 is 6, right? Now it makes it even more obvious that there's a 2 in both of them. And then I'm going to divide them both by 2. And that tells me what I should get. Now, I know it. For those of you that understand this might be painful, like, come on, it's so obvious. That's just x, and that's just 3, so it's x plus 3. Why is that so important? Because the people that bombed this test usually didn't notice the factoring, and then, dang, I guess that cancels that, and so the answer is just 2. I had a remarkable number of people leave an answer like this, negative 12x over negative 6x. Like, oh my gosh. Aren't there some things that would cancel there? Name one. There's 3 things that cancel. Name one thing that would cancel. The x's would cancel. You can do that? Yes. It's a multiply problem, so you can cancel stuff like that. And then, do you get there's negatives on the top and the bottom? Wouldn't those cancel? Yes, they do. In case you didn't know that, that would cancel. And now we're left with 12 divided by 6. Don't they both have a 6 in them? So the way I think you should do it, this is just my opinion. There are other ways, but I think you should go replace this with this, because that follows my little pattern. If you can factor it, you should. See why it's obvious now that it's just 2? All right, so a lot of people that struggled, it was about factoring. So let's do another one like that. Negative 28x over negative 14. Simplify that down. Did you mean for the x to be on the bottom, Mr. Server? No, I did not mean for there to be an x. To have an x on the bottom. There's just an x on the top on this one. In a moment, you're going to compare this answer with the kid sitting next to you. Okay, compare with the kid next to you. All right, first off, you should have noticed that the negatives cancel, right? And then if you just didn't have this memorized, I get it. Some of you don't know that 28 is twice as big as 14. If you didn't notice that it was just 2, I get it. You might not have known how to get to 2x real quick. But you could have gone, they're both even, right? If they're both even, then 2 goes into both of them. This would be 2 times 14 over 2 times 7. And that would have showed you that, oh, that would cancel that. And then hopefully you're smart enough to go, oh, 14 divided by 7, that's just 2. The answer was 2x. Be honest. How many of you had that on your iPad? You had 2x on your iPad. Okay, good. Here's the next one that a ton of people had trouble with because of factoring. This is not the exact problem on the test, but it's like it. All right. So first off, I think most people knew this, that this divided by this fraction means you're going to change it to times by and then flip it. So most kids knew this. Okay, I got to flip this to be 2 on top and x minus 7 on the bottom, and it's times. But then they got stuck right there. Some of you know that that's you, and you were like, well, I don't know, I guess I multiply it out. No! That's my favorite saying. If you can factor it, you should. All right. So what can factor? Can x minus 7 factor? No, that's just, there's nothing in both of them. Can 2 factor? No, it must be this thing. Everybody get that factored. X and x. If this number here is negative, right here, if that number is negative, then it's a plus and a minus. I think some of you did not learn how to factor when we had that chapter, or you've just completely forgot since then. And now one of these is a 7 and one's a 1. I know because this is negative that I want negatives left at the end, so I'm going to make the negatives kind of big. So I'm going to make it negative 7 and positive 1. But if you weren't that good at this and you had reversed them, you would multiply this and you'd realize, oh, I'm getting positive 6x and I want negative 6x. And then you would have switched the signs. But there, that's factored. Now, if you can't factor still, you need to come in the morning sometime to let me help you learn this, because it's so critical. Then this cancels this. Now, I'm surprised at how many kids still from there couldn't get it right. Would you please multiply it out and finish it? We only have 2 things left on the top, 1 thing left on the bottom, and then compare with the kid sitting next to you. So Blaine, so you and Grace and Aurelia, you guys each have something straight across from you today. Okay, compare with Aiden and Spencer. Okay, trying to look comparison. You want to compare with these kids in front of you, okay? These 2, you 3, you 2, you 2. All right. Please compare with the kid next to you. See what you got. All right, so here's me just rewriting the problem just to make it really clear. It's x plus 1 on the top and a 3 on the bottom times a 2. Now, some people get confused and think that that's a 2 on the top and a 2 on the bottom. It's not. That 2 is clearly on the top. There is nothing on the bottom unless you want to put a 1 down there. You could. And then I multiply it out and I get 2x plus 2 over 3. Now, could you have left it like this? 2 parentheses x plus 1. Over 3? Well, yeah, because my favorite rule is if you can factor it, you should. And this factors to this, that I think is even better. So if you answered it in either the red way or the blue way, I'm good with either one. Okay. Then the only other major mistake that I saw happening was on this kind of factoring. Man, a lot of people had trouble factoring stuff like this. 2x squared plus 3x plus 1. Tons of people couldn't factor this. So let me help you. A lot of people put a 2 out in front like this. No, that does not work. If there was a 2 in all 3 terms, sure, you could put a 2 in front. There is not a 2 in all 3 terms. So I think if you would have gotten started right, some of you could have got it, so I'm going to help. An x and an x would give you an x squared, but it wouldn't give you a 2x squared. You needed a 2x there and an x over there. These are all pluses. Makes it super simple. It has to be plus and plus. And then, my gosh, there's only one thing that multiplies to 1. It has to be a 1 and a 1. Now, how do you know that's right? First, 2x squared. Outside 2x, inside 1x makes a total of 3x. And the last is 1 times 1 is 1. It works. All right, here's another one that is like that. 2x squared plus 5x Hold on just a second, I gotta pause. There, 2x squared plus 5x minus 3. Everybody practice factoring that. Mr. K, tell me how to start it.
2x.
Good. And what's the other one over on the other side?
X.
Good. That's how you start. Noah, can I just use positives? No. Because there's a negative here, you need one plus, and you need one minus. Now, you don't know which one's which. You can't psychically know where to put the negative. So you just slap in a plus and a minus. Last but not least, there's got to be a 3 and a 1, because that's the only way to make a 3. We're not going to give you ones like 24 where there's like 7 different ways to do it. 3, there's only one way to do it. It's got to be a 1 and a 3. Now, I'm going to on purpose mess this up, because you're not going to know for sure which way it goes. And here's how you check it. First makes 2x squared. The last makes negative 3. So I know the first and the last are good, but it's always going to be here and here that get messed up. Around the outside, Christian, what do you get when you go 2x times the negative 1? Correct. And how about this 3 times the x? When I put those together, do they make positive 5x? No, they don't. So then, that isn't even close. Like if I switch the signs around, it doesn't fix it. So it's so wrong that I have to move the numbers. So I'm going to put the 3 here and the 2 here. Now I'm going to recheck it. Now, Christian, what do I get on the outside ones? The one around here. Negative 6x, good. And how about in the inside ones?
Oh, negative 2.
Okay, something's wrong. Why is it? Oh, it's not a 2? Mr. Server, what are you doing? 2 times 3 doesn't make 3. That's supposed to be a 1. Sorry. Okay, my bad. 1 times 3 makes 3. I should know that. Okay, so then 1 times x is x. Now when I put these together, x and negative 6x, I get negative 5x. Am I supposed to get positive 5x? Okay, so then if you get the opposite of what you wanted, you switch the signs around. That's a plus, and that's a minus. I know it took a while, but that's the hardest kind of factoring that you had to do. And there was one like that on your test. Not exactly like that. It was a little easier on the test because it only had positives in it, I think. Well, it depends on which test you took. There was different tests. Some of them were different. But anyway, that's all factored. That's the process of factoring. And then I wanted to start with that. All right, so the next thing I got to teach you for today is actually super easy. And I'm really happy it's super easy because it's just exponentials, and they look like this. Y equals 3 to the x. Everybody write that down. You just learned about how to graph 1 over x. This is different. Write this one down. Some people's hand didn't move, and I said write it down, and I can tell they haven't written it down. All right, next up is there's x squared, which was the old-fashioned one like this. There's absolute value of x. There's the one you just learned how to do, and that was 1 over x. Do you remember this with the asymptotes here and here? Okay. So here's a new one I got to teach you. Exponential graphs, they look like that. That's called exponential growth. If it starts out slow and then gets faster and faster and faster, like goes up really, really steep, that's exponential growth. Bacterium can just go insane. In like an hour, they can times themselves by 5. So like if you're getting sick and it seems like you're getting sick really fast, that's what can happen. Is you get sick and all of a sudden these cells are multiplying. They're the bacteria. Okay, so if you have a bacterial infection, they can be like quadrupling in an hour. All right, so that's what exponential graphs look like. But you really just need to know the old XY chart. And we had to know that for this test too. So let's practice that, because also that'll help kids that have to do corrections and a retake on the test. This is different, but it's kind of the same. All right, everybody put in 0, 1, 2, and put in one negative number. We're going to put in -1. Now, when I say put the numbers in, where are you going to put them? Where the x is. So, Blaine, that first one is 0. Do you know what 3 to the 0 is? Do you have it memorized?
Isn't it 1?
It is 1. Very good. Anything to the 0 power is 1. If you didn't know that, you'd have a calculator. You'd type in 3 power of 0 and you get 1. Now let's put in 1. 3 to the first. Well, everybody can do that. That's 3. Then put in 2. 3 to the second. Look, it says y equals 3 to the second is 9. Look at that. So now I got 2 comma 9. See, that's growing really fast. I put in 2, I get 9. That's like, I put in 2 and all of a sudden it's way up there and it's growing really fast. What about -1? This is one of those powers that you need to remember. When I have an x right here and I put in a -1, do you know what putting something to a -1 power does? You remember, Noah? It flips it, so 3 becomes 1/3. Process that for a minute. Whatever was here, it becomes 1 over that. So -1 power makes things flip over. All right, so when I put in an x is -1, I got 1/3. Now watch if I graph these things. 0, 1, 1, 3, 2, 9. Look at that. That's the super steep part. And -1, 1/3. That means I go over this way 1, -1, up 1/3. Look at that. Super steep. Kind of like the bacteria that when you get sick, they're multiplying inside your body. All right. Noah, you need to go get a drink. Well, that's kind of weird, but I think it'll wake you up. All right. So this is exponential growth. What's it called when you have exponential decay? It's called a decay function. And that looks like this. That's what happens when you have like the moose population in Minnesota and it's shrinking. It doesn't just shrink to overnight to 0, but the moose population in Minnesota, in truth, in real life, it was going down. There was less and less and less moose. But it's not like they're just going to all die out one day. You're going to just have less and less and less and less. And if you get down to 1 moose, then that's pretty much it, right? Game over. In fact, if you even get to less than like 10, then all of a sudden it's pretty unlikely they're going to survive. So, in Minnesota, the moose population was shrinking. It's actually turned the corner now and it's started to grow a little bit. But there's other things that are shrinking. Like there was the dodos type of a bird that was actually a fair amount of them around. And then all of a sudden during, recorded history, all of a sudden there's less and less dodos and pretty soon they're just gone. They just don't exist anymore. All right, so that's called exponential decay. And what that looks like is something like this. Y equals 1/2 to the x power. See, that one goes like that. Let me prove it to you. XY chart. It's always about the XY chart. This is why this is so important. It was on the last test, too. If you couldn't find the number on that chart, please come up and ask me how to do that today, because that's so important. It's not as important as factoring. Factoring is going to come up forever. This graphing stuff is huge. So if I'm going to put a 1 right there and you can't figure out what the answer is, that'd be so scary. If I put a 1 in, what's the y? Y equals 1/2 to the 1, which is 1/2. How about if I put in a 2? How about if I put in a 0? And how about if I put in a -1? Would everybody please get these 3 points? Already got them? Okay, just find those 3 points. Just look distracted. Don't have it out in your list. David, we're gonna put in a 2. What do you get? Two goes here. You know what it means to square something? So then this gets squared and this gets squared. So what's 1 squared? Yep. What's 2 squared? So the answer is 1/4. So when you put in a 2, you should have gotten 1/4. So I need to get a feeling, how many of you actually figured that one out? Okay. All right. So what if I put in a 0 power? Ooh, that's one of the kind of cool ones. Y equals 1/2 to the 0, because the answer is super easy if you know what to the 0 means. Noah, do you know what 1/2 to the 0 is? Very good. So this one was 1. And how about -1 power? 1/2 to the -1. I taught you that 2 seconds ago. -1 power flips it over. Very good. And the answer is 2. Y equals -1 power, flips it over, 2. If you graph those, everybody do it. You'll see the exponential in reverse. It's like a flipped over exponential graph. It shrinks instead of grows. 0, 1 is like right there. -1, 2 is like above it. Well, that makes sense because it's going to be going down as you read from left to right. 1, 1/2. It's like here-ish. 2, 1/4. That got a little lower. Do you get the feeling if we keep cutting this in half, it'll still never touch 0? Do you remember that kind of asymptotic behavior where it gets closer and closer to 0 but never touches? That's because there's an asymptote running right across there. So how do you figure out where the asymptote lives? It's all in whether the graph's been moved up or down or not. So watch this. Y equals 3 to the x. The asymptote's still at 0. It's right here. It'll pretty much always be at 0 unless I move the whole thing up 2. Do you get then the asymptote would have to move up here? So it's the exact same as that other kind of graph where you just say y equals whatever's on the outside. That's the horizontal asymptote. Remember the one that was on the outside here? Whatever was out here, that was the horizontal asymptote. See, it's right here. And it wouldn't be here anymore. All right. So, they're going to give you some graphs, and you're going to get some points. And once you get a bunch of points, if anybody in here can't like look at these points and know where it's kind of going, then I'd be really surprised, because I think everybody can go, oh, that's doing this. Once you get the dots, it's easy. So how do you get the dots? XY chart. So what if the problem looks different though, Mr. Server? There's a 3 in front of it. You still do the exact same thing. You pick 0, 1, 2, and maybe one negative number. -1 is a special number because it makes things flip, right? So I'd like you all, even though there's a 3 times 2, yes, it's the same exact thing. Just stick in 0 for x, see what you get. Stick in 1, see what you get. Find those 4 answers. And then it's about time to set you loose on your homework and give people that have retake to work on, give them some time to come up and ask me how to fix their problems. Veda, can you just help explain when I put in 0? What do you do when you put the 0 there? What do you get? What does this part turn into? 1. So what should I put right here? 3 is correct. 0, comma 3. Who had 0, comma 3? Okay. Amir, when you put in a 1, what'd you get?
6.
Correct. Victoria, when you put in a 2.
12.
4 times 3 is 12 is correct. And last but not least, Spencer, you put in a negative 1. Do you remember what that does? Yep. Doesn't flip everything, but it flips the 2, so the 2 turns into a... Yep. And 3 times 1/2 is 3 halves. 3 over 2, also known as 1.5. And now if you graph this thing, 0, 3, 1, 6, 2, 12, negative 1, 1.5. Looks like it's about there. Can you connect the dots? I hope so. But I hope you remember that there's an asymptote running right along there at 0. How come I know it hasn't moved? Because there's nothing outside. If they would have put something like a plus 4 here, then all of my points would have been shifted up 4, and there would have been an asymptote at y equals 4. But there's nothing on the outside, so then the asymptote is at y equals 0. That's where the asymptote is. Just like before, it's the thing on the outside. All right, this is the part where we need to go find the worksheet. We'll do a couple together. Everybody open up the worksheet that I gave you for homework. Dashiell, read me number 1 of the worksheet. Okay, I'll pause for a second. Okay, y equals 2 to the x, and what does it ask you to do?
Graph following and question.
All right, so let's do the graph the following. XY chart. Vivian, what numbers did I say I usually stick in?
0, 1, 2, -1.
Very good. You got to have one negative number, and the only negative number that works really nice is negative 1 because it just flips the number over. So let's go ahead and do that. If I put in 2 to the 0, 2 to the 0 is 1. That's pretty easy. If I put in a 1 here, 2 to the 1 is 2, 2 to the 2 is 4, and 2 to the negative 1 goes in there. 2 to the negative 1 flips a 2. What do you get when you flip a 2? It's like 2 to the negative 1 power. What is 2 to the negative 1? Come on, say it. I can wait all day. Come on, say it. 2 to the negative 1. Nobody in this room knows what 2 to the negative 1 is.
So it's 1/2.
It's 1/2. Thank you. All right. So now 0, 1's here. 1, 2 is here. 2, 4 is here. Negative 1, 1/2 is like right there. Hopefully you got the idea that once you get all the dots, it's obvious where that goes. And then there's always an asymptote here unless the whole graph has been shifted up. Was there like a plus 5 here? No. If there was, the graph would have been y equals 5. But there's only a 0 here. Y equals 0 is the horizontal asymptote, the horizontal. All right. How many problems are there on the worksheet? 5?
No, there's
4? All right. That's a very doable sized worksheet. I'm just going to sign those 4 questions. I did the first one with you. There might be some follow-up questions, like where's the asymptote, or is there anything else that they ask besides like simple? Is there anything else number 1 asks besides graph it? Okay, cool. Then you guys work on that, and now I'm going to hand back those tests, and then the people that really bombed the test, you got to focus on your corrections during this time. And that's all I got for you for the video for today.